Hello children, welcome back. We are doing the revision on chapter number 2, polynomials, which is going to come for the first periodic test, right? In the last session, we have already discussed, I think maximum we have already covered what is going to come for the exam, children, like what are polynomials, types of polynomials. Then we have seen p of x, right? When the x value is given, how to find. Then we have seen whether the given is a factor or not. We have seen the remainder theorem. Then we have also seen the how to factorize the given polynomial when there are three terms, right? So middle term you have to split. So these all topics we have covered, children, already in our last two sessions. Now today's children, we are going to discuss exercise 2.5, which is not there for exam. Okay, so children, again I'm telling exercise 2.5 is not going to come for the exam, children, that is first periodic test, but still it is a very important exercise and many of them wanted to know sums once again from that exercise. So today we will discuss exercise 2.5. So let us begin, children. Yeah, now factorize. This is 2.5, question number 5. All right, so now you can see here factorize. This 2.5 exercise, maximum all the sums are based upon the identities which you have learned, children. That is the identity number 6, 7 and 8. So you have to first of all learn all the identities. Then you can relate your sums with that identities. So now if I see here, if I count all the terms here, if I count the terms, here are 1, 2, 3, 4, 5, 6 terms in the given question, children, right? So that I can think which identity I can use over here. So 6 terms I have only in one identity, that is which we have learned, that is a plus b plus c whole square. Like that also you can first think, relate, and then go ahead with the solving. Okay, so now here you can see we will begin. Yeah, it is 4x square plus 9y square plus 16z square plus 12xy minus 24yz minus 16xz. First of all, I need to write this whole term in the form of a square, that is whole square. So 4 I know is a square of 2. So I will write that term as 2x whole square. Understood, children? It was 4x square, but I want this term whole square. So this 4 I will write it as 2 square and x square as it is, both squares, that is I can write it as 2x whole square. So similarly for other all terms we have to write, that is 4x square is written as 2x whole square. 9y square is written as 3y whole square. Then 16z square is written as 4z whole square. Once I got all these and the rest of the terms I have written as it is. Now if you see, children, here we got a square, b square and c square, that is 2x square plus 3y square plus 4z square. Now another terms I will write it in the form of 2ab plus 2bc plus 2ac. So let us try. So 2ac is nothing but 2 into a value is 2x into b value is 3y. How much I'll get, children? It is 2 into 2x into 3y. So how much I'll get? 2 multiplied by 2, 4. 4 into 3, 12. 12xy. Yes. Is it equal to this term, that is 12xy? Yes. So this 12xy we have written as 2 into 2x into 3y. Similarly, other terms also I have split into the same way, that is 2bc and 2ac. that is 2 into 3y into minus 4z, that is b and c value, and 2 into a and c, that is 2x is a and minus 4z is b value. So now next one is, now we are going to just compare it, children. Okay, that is, it is now in the form of a square plus b square plus c square plus 2ab plus 2bc plus 2ac. Yes, you can see here a square, b square, c square plus 2ab plus 2ac plus, 2bc plus 2ac. Now this I can equate it with whatever is the left hand side. So what is the left hand side over here? That is a plus b plus c whole square. Now I know the values of a, b and c. Let us just substitute the values. A is nothing but 2x plus b is nothing but 3y plus c is nothing but minus 4z. C value is negative 4z. So as it is negative 4z whole square. Now whole square is nothing but, we got here two factors. This is nothing but this whole square. I'm just writing into separate two terms, right? That is 2x plus 3y minus 4z. Again in the bracket 2x plus 3y minus 4z. So these are the two factors of the given polynomial. So you have to just substitute the values according to the identities, children. Knowing the identities is very important. Every sum you have to do the same procedure. Now let us move ahead. So this is the next one again. Factorize each of the following. Now if you see here, children, there are how many terms? 1, 2, 3 and 4. And we have these 4 terms in our identity number 6 and 7. That is the x minus y whole cube or x plus y whole cube. So we will try to use this identity and factorize the given polynomial. So if you see here, it is 64a cube, which is written as 4a whole cube, because I know 4 into 4 is 64. 4 cube is 64, right? And then 27b cube is written as 3b whole cube, because 3 into 3 into 3 is 27. That is 3 cube is 27. Again, the 144a square b will be as it is. 108ab square will be as it is. Now if you see here, children, we got our x cube value, y cube value. So let us substitute in the form of 3xy into x minus y. So 3 will be as it is. Now you can see here this one minus 3. Now x value is 4a. I'll take it as 4a. Into y value is 3b. I'll take it as 3b. Into 4a minus 3b, that is x minus y. Now if you calculate this, it will be equal to this what you got over here. Let us see, that is 3 into 4a into 3b. Now if you see here, 3, everything is in multiplication form. 3 into 4 into 3 will be 36. Minus sign is there, so minus 36. AB as it is, and in bracket 4a minus 3b, which is nothing but equal to the same what we have here. That is 36 we have taken common, 36ab from 144a square b plus 108ab square. Right, children? So now comparing what we got with our identity, that is x minus y whole cube. It is in the form of x cube minus y cube minus 3 into x into y multiplied by x minus y. So hence we can say that this is equal to x minus y whole cube. So hence we can write as in the form, this we can write in the form of x minus y whole cube. So x value we know it is 4a minus y value we know it is 3b and whole cube. Now whole cube means same bracket we can write in the multiplication form of 3 times, that is 4a minus 3b, right? Multiplied by again 4a minus 3b, multiplied by again 4a minus 3b. So these are the three factors of the given polynomial. So once again I'm telling you have to just concentrate how to split the terms and according to your identities. So other sums you can try it by your own children. Let us move ahead. That is again factorize, which again we have to use the same identity, that is x minus y whole cube is equal to x cube minus y cube minus 3xy into x minus y. So here again you can see children 27p cube, and 27 I know it is a cube of 3, right? So this 27p cube I can write it as 3p whole cube. 1 upon 216 I can write it as 1 upon 6 whole cube minus sign as it is. Then minus 9 upon 2 p square as it is plus 1 upon 4 p as it is. Till here clear children? Now first second term as it is, that is x cube minus y cube, it will be in the form of, now this one I will write it in the form of 3 into xy into x minus y. So let us see, first I will write minus 3 into xy, that is minus 3 as it is, right? X value is 3p and y value is 1 upon 6, right children? Now if I calculate this children, so it will be, yeah, and another bracket is x minus y, that is 3p. I'll do one thing, I'll make a smaller size so that you will understand. Yeah, once again I'll write children here, it is 3xy into x minus y. All right, so this 3xy, negative 3xy is multiplied to x as well as multiplied to y children, right? So now if you see here, this whole thing is multiplied to 3p as well as it is multiplied to minus 1 upon 6. So if you multiply the first, this one, you can see here it is 3 ones are 3 twos are. So in the denominator I got 2 and in numerator 3 threes are 9. So this is minus 9 upon 2 and p will be p square, as well as the same thing is multiplied to the, this whole is multiplied to the, this term, that is the second term in the bracket, that is minus 1 upon 6. Now if you see here 3 ones are 3 twos are, that means in denominator again here one more 3 ones are 3 twos are. So 2 into 2 will be 4 and in numerator nothing is there, means 1 and p as it is from here. So this is how we have split our terms, right? And now this you can see is equal to x cube minus y cube minus 3xy into x minus y. So now hence we can say that this is equal to x minus y whole cube. So x minus y whole cube will be 3p minus 1 upon 6 whole cube. Here I have just substituted the values of x and y, which is equal to 3p minus 1 upon 6 into 3p minus 1 upon 6 into 3p minus 1 upon 6. Right children? These are the factors. So let us proceed today. Yeah. Give possible expressions for the length. Now these are the application based sums children. Length and breadth of each of the following rectangle in which their areas are given. Now first one we will see, area is given to you. Okay, you have to just factorize and find out the two factors you will get. One will be obviously length and the other one will be breadth, right? So let us see how to factorize. This is already we have discussed children, when there are three terms you have to split the middle term. This method we use, right? So in such a way, the two numbers you have to take in such a way that their product should be equal to the product of first and last numbers. right? And sum should be equal to the middle number. That is, now here you can see sum should be equal to the minus 35, which is here, and 25 multiplied by 12 is nothing but 300. So you have to take such numbers that their product should be equal to 300. Now if you see here in the table, it is shown here. Okay, so such product you get by different numbers. Sorry. Yeah, so such products you can see, you get by 12 multiplied by 25, you get by negative 6 and negative 50. There is minus 15 and minus 20, but sum is satisfied only by minus 15 and minus 20. So here we will split our middle term as minus 15a minus 20a, and the first and the last term keep it as it is, children. Now from first two, take out the common, whatever is coming common. So I can see a is common, a is outside the bracket, and 5 is common, so 5a outside the bracket, and remaining terms will be inside the bracket. That is 5a minus 3. How you will check? 5 5s are 25. A multiplied by a is 25a square. And again 5 into 3, 15. That is 15 and a, so 15a. So like this, you take common from the other two terms also. That is minus 4 common, 5a minus 3 in the bracket. Now here, if you see, the brackets are same. So this will be my one factor, that is 5a minus 3. And remaining other two, I will take in the other bracket, that is 5a minus 4, which is my second factor. So this is, one is length and one is breadth. So this is how we have to solve when there are three terms, children. Middle term you have to split it, right? So let us proceed. What are the possible expressions for the dimensions of cuboids? Now if you see cuboid, we should get three factors, that is length, breadth and height, right? So let us see how that we have solved here. It is 12ky square plus 8k minus 20k. If you see all these numbers, we can take 4k common from all the three terms. So here we have taken 4k common, and remaining we have written in the bracket, that is 4 3s are 12 ky square, 4 2s are 8 ky, and 4 5s are 20k. Right, children? So here this is how we have taken the common from all these terms, three terms, that is 4k, and remaining in the bracket. Now this bracket, again if you see, there are three terms. In the previous slide I have told you, when there are three terms, we have to split the middle term in such a way, in such a numbers we have to take that their sum should be equal to the middle term and product should be equal to the product of the first and the last term. So likewise we got here the middle term 2y, we have split into 5y minus 3y, right? And again from the first two terms we will take common. In the last two terms we will take common, remaining in the bracket, and here we got common bracket as 3y plus 5, and remaining y minus 1 will be in the other bracket. Now if you see, here we got our two factors, and don't forget 4k which we have taken outside. So this is our third factor. That is, here you can see, children, it is 4k multiplied by 3y plus 5 multiplied by y minus 1. So one is length, one is breadth, and one is height. So this is how you have to solve, children. Basically the basic concept of factorizing you should understand. Using of identities you should understand. You have to practice this. Okay. Now here is one more. Without actually calculating the cubes, here again you have to use your identity. You have to not calculate the numbers, children. Use the identity, substitute the values, and automatically you will get your result. So now you can see here it is negative 12 whole cube, 7 cube and 5 cube. Now I know we have an identity x cube plus y cube plus z cube. Minus 3xyz is there, that we will transpose it to the other side. It will become plus 3xyz. Now here you can see plus 3xyz and remaining terms as it is. Now here we will substitute the values of x, y and z. So after substituting, you will get 3 into x into y into z. Now x is what? Minus 12, y is 7 and z is 5, right? So 3 into x into y into z plus whatever it is, x plus y plus z into x square plus y square plus z square minus xy minus yz minus zx. So this is how we have substituted our all the values of x, y and z. Now after substituting, now you have to solve all the brackets one by one, children. So that will be you can see here, this is the same, okay, plus you will get here 0, that is you will get 7 plus 5 12, negative 12 positive 12 will be 0, okay, and 0 multiplied by whole bracket will again you will get 0. That means only this bracket, that is this terms are remaining, that is 3 into minus 12 into 7 into 5, which gives you negative 1260. That's it. You have to just substitute the values, children, and solve it. One more is there, children. If x plus y plus z is equal to 0, show that x cube plus y cube plus z cube is equal to 3xyz. Now we know x cube plus y cube plus z cube minus 3xyz is equal to x plus y plus z multiplied by x square plus y square plus z square minus xy minus yz and minus zx. This is, we have our identity, right? So now in this identity, what I'm going to do is x plus y plus z value they have given us as 0. So let us substitute this value as 0. Now this multiplied by whole bracket, 0 multiplied by anything is answer is 0. So I will get here right hand side complete 0. Now left hand side what is remaining, children? X cube plus y cube plus z cube minus 3xyz. It has been asked that it is x cube plus y cube plus z cube only. So this remaining minus 3xyz, I'll transpose it to the other side. It will become plus 3xyz. Now what is there? So hence this is proved. We got automatically x cube plus y cube plus z cube is equal to 3xyz. So hence it is proved. It is very easy, children. You have to just substitute the value of x plus y plus z. Let us see the last one, children. Verify that x cube plus y cube plus z cube minus 3xyz is equal to half into x plus y plus z multiplied by x minus y whole square plus y minus z whole square plus z minus x whole square. So let us start solving first the right hand side. So right hand side I have taken here. If I see in the right hand side, it is x minus y whole square, y minus z whole square, z minus x, which is in the form of a minus b whole square. And we know the value of a minus b whole square is equal to a square plus b square minus 2ab. Or you also say a square minus 2ab plus b square. So this again we have to, these brackets again we have to expand in this way. So a minus b whole square will be a square plus b square minus 2ab. Again a square plus b square minus 2ab and a square plus b square minus 2ab. I have just substituted the value of a and b as given in our question. So here now this is equal to, again I see here, children, when I expanded this all brackets, I see here x square, everything is in multiplication, right? And plus, so it is this bracket is added to this bracket and added to this bracket. So each bracket if I observe, I can see here is x square and here is x square. So can I write 1 plus 1 x square is 2x square, right? Y square plus y square, can I write it 2y square? Z square, 2z square minus 2xy minus 2yz and minus 2zx as it is, right? Now if I see in the next whatever we got, that 2 and 2 common. So in from this whole this bracket I have taken 2 outside common and remaining terms as it is. Now if you see here, we have here half, right? So in the denominator 2 and here in the numerator 2 gets cancelled, and remaining terms are x plus y plus z in the bracket multiplied by x square plus y square plus z square minus xy minus yz minus zx, which is nothing but equal to x cube plus y cube plus z cube minus 3xyz in our identity. So hence we can write this, hence proved, it is equal to x cube plus y cube plus z cube minus 3xyz. So I hope maximum we have covered, children, those who are having doubts. So for today we will stop, and best of luck for your exams. Do well. Thank you, children.